I'm Peter Todd. I've done a lot of work around Bitcoin. I have made some contributions to Bitcoin Core, which leads some people calling me Bitcoin Core developer, although I haven't done that more lately. I've also gone and worked on a lot of projects that are building on top of Bitcoin, and Open Timestamps is one of them. So without further ado, I'll get talking to how I use Bitcoin to help timestamp an election. And if I want to go talk about that, well, you got to go start with what is a timestamp. And a good analogy is it's basically carbon dating for data. And if you're not familiar, carbon dating is the scientific process by which things like archaeologists determine how old things containing carbon are. And what that really tells them is, well, assuming a bunch of scientific assumptions, basically the carbon in this thing is a certain number of years old because of the difference in radioactive isotopes. It's a bunch of interesting science, but the important thing is it says, hey, this thing's old. Well, the equivalent for digital data is useful for a very interesting reason, which is that there's a time machine, and time machines don't exist, which means that the bad guys don't have one. And very frequently with digital data, you can be in a position where if you can rule out something happening to that data, maybe editing it, maybe creating it, maybe modifying it, whatever, if you can rule out that before a certain time, if you can prove the data existed prior to that time, you can rule out an attack. Now, there's a lot of caveats to this statement, and I'll discuss that more later. But one of the most simple ways this is used is in digital signatures. And I don't know how many of the audience here has ever used Git, but if you have, you probably know that Git allows you to digitally sign software with a PGP key. And the problem with PGP is, well, a PGP key, like any digital key system, involves a secret that needs to be kept secret that's then used to drive a pub key. Well, in this case, Peter Wool, much more famous Bitcoin developer than me, that's his digital signature, but it says right there, maybe a little hard to read, this key is being revoked by its owner. Could mean the signature's forged. Well, why did that happen? Because Peter Wool accidentally stuck his private key on a public server and realized, oh shoot, I should go fix that. And without a timestamp, there is now no way to verify the signatures, right? You don't know when they were created. Maybe they were created yesterday by the bad guy who stole that secret key. But if you can prove that those signatures were created in the past, prior to Peter Wool fucking up and leaving his secret keys in the wrong place, then you can still validate them. So here's another example of a Git commit in Bitcoin Core. And what do you know? It's signed by me back in, 2017. And this one is timestamped. This one is timestamped with Open Timestamps. Go prove, hey, that thing was actually created as of February 19th, 2017. And in my case, I haven't screwed up with my private keys, but if I do, you'll still be able to verify that. Another interesting example of this being used is something called proof mode, which to capture, share verifiable photos and videos. And proof mode has a lot of moving parts to it, but one of the things that it does is it timestamps photos. And I'm actually told this is getting used here in Ukraine to go document war crimes evidence. And the role of open timestamps in that case is, well, when the photo is captured, the timestamp proves that that digital data existed prior to that point in time, and anyone who wants to later challenge it basically has to come up with a story as to why that particular data could have been faked at that time. Now, obviously, sometimes that's not a very useful proof. Sometimes you're creating, digital data that could have been faked when it was created, but many times you're not. Many times, you capture something where the significance of it isn't known till later, and being able to say, hey, this thing's old prior to, this other thing happening is still useful. But as I'll explain, the way timestamps work means that adding them is extremely cheap, essentially nearly free. And let's go into some details for what's actually going on under the hood. So the basics of a timestamp from a mathematical point of view is something called a commitment operation. So it's a proof that one message existed prior to another message. And if you can show that relationship, and if you can extend this multiple times, that lets you say something about when data might have existed. And open timestamps under the hood is basically a proof of a set of these commitment operations. Well, let's give you a concrete example of one. What if we have an operation that simply prepends a fixed string to another string, right? That's a commitment operation because the first message was repeated in the second message. Sounds kind of stupid, but it's a building block, right? It's an example of that math. And if you run this with like hello and world, you get hello world, But the more interesting thing is that hash functions are also commitment operations. And I'm kind of curious, show of hands, how many people think they know how a hash function works? Reasonable number. Well, I'll give you a quick explanation. So, in mathematical terms, we kind of call this a random oracle model for cryptographers. But really the way you can think about it is the number coming out of a hash function is really big. It's 2 to the power of 256, or 256 bits. And that's an enormous number. Like that's, I'm probably going to get slightly wrong, but that's on the order of like the number of atoms in the universe. It's that kind of enormous number. Well, imagine if for every single piece of digital data possible, you just randomly picked one of those enormous numbers. Well, because that space is so big, it's completely infeasible to find two messages that hash to the same output. They exist, they have to exist, because the messages coming in are bigger than the ones coming out. If you're a bit familiar with some math that's called like the pigeonhole principle. There's only so many holes for the pigeons, and obviously if more pigeons than you have holes, well, some pigeons are going to have to double up. But because the space of hash digest outputs is so big, it's totally infeasible to find it. And that makes a hash function a commitment operation, because the only way a human being can in reality find the output of a commitment of a hash function is by knowing the input. And that establishes a relationship in time. And then the final bit of the puzzle is Merkle trees. Now remember when I said a hash function could take any size input? Well, we can scale this by creating a tree of all this data and using each step here, taking two pieces of data and turning it into one of the same size. Well, if you repeat that over and over again, you get one piece of data that mathematically depends on all of the things at the bottom. If this seems a bit confusing to you, read it on Wikipedia. It's a nice explanation. But the important thing is that top hash was derived from everything else, which means if we find a way to establish that top thing in time, we can prove when all that other data might have existed. Well, prior to Bitcoin, that's exactly what the guard time company did. And not the easiest thing to read, but this is an actual newspaper dated, 2009? Oh, funny enough, yeah, but after Bitcoin was created. And guard time did this Merkle tree thing and a few other things, like including a blockchain. But the important thing is that they were timestamping stuff, but their root of trust, their connection to time, was they would publish these root hashes in actual newspapers. They'd go spend probably like $10,000 getting that little thing, and these newspapers are all over the place. So if you wanted to screw up one of these timestamps, you would have to go around to all the newspaper archives and change that piece of paper. Obviously quite difficult, but also not that easy to verify. If I really want to know if a guard time digital signature is correct, am I really going to go down to like the local library and verify that? It's kind of a pain. Well, my project Open Timestamps uses Bitcoin to go fix all this because Bitcoin blocks have a time associated with them. And for various reasons, that time is roughly correct. And, I could give another 30-minute talk on how timestamps works, but the important thing to take away from it is Open Timestamps is software that anyone can use. You can hit, you can type OTS stamp, and it will give you a timestamp proof that's verifiable to Bitcoin. Totally free to use. The only cost is really some network bandwidth. Because it uses Merkle trees, it's extremely efficient, so I can run the whole service on donations, and I'm one of like 3 people running the centralized parts of it. And since it's math proof, you're not trusting me. Well, so back to the main topic of it. With this, well, what might you want to do with it? Well, you might go want to timestamp an election. And what I think is interesting about this project is I wasn't initially involved in this. The people who did this, they just knew about open timestamps from the website and thought, this is a good idea. So, what's the background here? Well, we're talking about the Guatemalan election, and like most elections, it's a paper ballot system. So these are the actual ballots, and you go put a cross through it to vote for which person you want. Guatemala has fairly low levels of literacy compared to many other places, so you get the nice photo to see who you want to vote for. They prevent double voting with this clever ink on the finger system. So when you vote, you're forced to go and put ink on your finger, thus you can't go to another polling station and vote twice. And if you happen to not have a finger, they have a whole set of rules for exactly, all right, well, we'll use the next finger, the next finger, the next finger, we'll put it on your forehead eventually. It's quite a funny system, but it does work. And so far, everything I'm talking about is analog. Well, what do you do with all these votes? There's polling stations all over the country, on the order of like 100,000 individual polling boxes, and people, thousands of people, including observers from every party, they open up these boxes and they put them on tables and they go and count them. And that is the tally sheets. For each individual voting station, those numbers are actually a group of people counting the ballots and deciding how many votes were for which candidate. Now the next step, once you've done that initial tally, is, well, you got to start doing tallies of tallies, right? If you have 100,000 voting boxes, you got to go report those results. And this is where open timestamps comes in. So they have a preliminary results system which scans in these things and puts them into a database. And what open timestamps does is they manage to convince the election authorities to allow open timestamp software to be installed on the server that all this reported to. So as ballot images came in, literal JPEG scans, they would immediately get timestamped. And there's me at Election Central going and watching all this go happen. And I'll stress, my role there really was just a consultant. I did a little bit of software for a small part of this, which I might get to later, but mostly it was the people in Guatemala who wrote all this. In fact, they only called me in probably, 4 or 5 weeks maybe before the election. And that's when I learned that they'd done all this. And in fact, a couple of years prior, they'd also done this unofficially by just running a script that would go to the government website and download all the ballots. But, it's quite a big event. And funny enough, when you go start this whole system, they had a whole big silly ceremony where, all the dignitaries get up on the stage and they type in the little magic command to go start the counting and all this. And part of the thing there is like a formal document saying, hey, we've actually started the election. Well, unbeknownst to us, I went and timestamped the thing, and we had a very awkward moment when it was like, dude, do they realize Bitcoin blocks take 10 minutes at least? Are they waiting for the timestamp to confirm? What's happening here? But they eventually decided to skip to the next part. That sounds all well and good. Well, where does this lead? The challenge we had was, as often is the case, there were accusations of election fraud. And in fact, these accusations look to be pretty correct. I am told, maybe I'll step back a second. The digital data that we timestamped, you can analyze that data and you notice a pattern. Nearly every single polling station, the digital image was timestamped within roughly an hour of when the polls closed. Approximately that, which sounds about right? You open a box, put it on a table, a bunch of guys sit there counting stuff, someone puts in the sheets in the scanner. About an hour, sounds about right. Well, in one part of the country, namely Guatemala City, all of the timestamps were hours late. Some of them would come in 16 hours later. Well, you got to ask, what could he have done with a bunch of ballots with 16 hours? What if you decided to go change those numbers, right? 16 hours is plenty of time to go change some numbers. And there's also eyewitness evidence that, sure enough, people at these polling station said, hey, a bunch of guys who were not the election officials came in and took the boxes and then brought them back later with the seals broken. And apparently, a lot of the ballot sheets, these numbers would just be crossed out and new numbers written next to them with a timestamp 16 hours or so, after, like 16 hours after it should have been scanned in. Obviously, this is kind of suspicious. Well, what did open timestamps do here? The New York Times article on this is kind of interesting because the way it was written was from a very US perspective in terms of election denial. It was saying, hey, if the election deniers succeed, Guatemala lost the battle for democracy, they're claiming the votes fade, and so on. But from what I'm told, and again, I'm not an expert on Guatemalan politics, but what I'm told is that part of the ruling party who were losing the election decided, you know what? Why don't we go and deliberately throw the vote in a way that's easy to show, right? If the vote is obviously miscounted, is obviously tampered with, maybe we can do another election, right? Maybe we can get another 6 months to campaign and maybe we'll try to win again. And interesting in this case, open timestamps' role is not actually to go prove fraud. It's to go and provide convincing evidence that the vast majority of the election happened without a hitch. Now, I cannot prove with a timestamp that a ballot coming in, 16 hours after it should have is fraudulent. I know maybe someone dropped it on the floor and just didn't find it for a while, right? A timestamp cannot prove that. But it can certainly provide convincing evidence that maybe the other ballots were okay. And in that context, given Guatemala City is just a small part of Guatemala, well, long story short is the election results were allowed in and the ruling party lost. And in the meantime, well, it was a whole mess. My clients who I worked with, I think I can go say this now, but for a while they actually left Guatemala because they're worried for the safety. The ruling party is a bunch of thugs and they figured they really don't want to go be there. And even just getting paid took quite a while because they were trying to go and get various aspects of the whole election machinery in jail. My understanding is some of the contractors did get arrested, although fortunately not my clients, but it was a real mess. But in all this real mess, the fact is, open timestamps is independent of all this. It's just a mathematical proof. It goes back to the Bitcoin blockchain, which is much bigger than Guatemala, which is very widely witnessed. Everyone here who runs a Bitcoin node has themselves independent evidence of when Bitcoin blocks were created. And in fact, one of the things I did do for this project was I created software to independently timestamp Bitcoin blocks with trusted timestamps, a system called Roughtime. You can go look it up. And the trust of that goes back to Cloudflare, among others. And that's the beautiful thing about timestamps. You can always add different timestamps together. One piece of evidence that data existed in the past is compatible with a different piece of evidence that data also existed in the past. The constraints on when the data might have been created could change, but you can always go add that together. On the other hand, and I'll leave with this cautionary note, timestamping is not perfect. Just knowing that data exists in the past is not necessarily enough. It certainly is possible that someone could have hypothetically created an entirely different set of ballots and timestamped all of them to create a fake narrative for the election. Had they done that in advance, absolutely you could have a bunch of timestamped images that look like ballots. And one of my suggestions to my client to improve on this was to at least set up a system where all the ballots as a group were hashed together so that you could at least say, hey, this group existed at a time. But, there are limits. Ultimately, a lot of the security of this really comes down to the fact that human beings count pieces of paper. And if you want to sabotage this process, you need a heck of a lot of human beings and a whole lot of Guatemala to sabotage it. But, open timestamps did its part, and I'm happy with that, and hopefully we'll see it more in other elections. So with that, thank you.